Hi, this is Sue Berk. Welcome to my podcast. Artificial intelligence and the future of humans is a book-length topic. So why am I trying to talk about it in a podcast in 15 minutes? Or maybe even 10? Because it's interesting. So how do machines learn? Is the power of machine learning all that powerful? Let's tackle this topic, at least the basics. I can't remember the last time I called a company and a human answered the phone. And if you're calling Comcast, eat lunch first so you don't get hangry. In fact, computers are calling me, and not to go to lunch. Heck, my friends don't call me for lunch dates either, they text. Phones brings me back to Siri, Alexa, and artificial intelligence. And for the record, I am skipping the chess stuff. To evaluate artificial intelligence and the future of humans, like computers, we need data to draw from. I promise this will be a brief history of artificial intelligence. I'll be speedy quick, like the power of machine learning. In the first half of the 20th century, science fiction reacquainted us with the concept of artificially intelligent robots. One could argue that Frank L. Baum's Tin Man from The Wizard of Oz is a kind of artificial intelligence. Tin Man is a long way from HAL, the AI in 2001, A Space Odyssey. In this movie, an AI takes a darker turn, and you should watch it if you've never seen it. It is a classic. Do Androids Dream of Electric Sheep by the great Philip K. Dick inspired Blade Runner, another dystopian AI-themed work, also a classic. The 1980s brought Neuromancer, The Matrix, The Terminator. Watch the original if you haven't, because even in spite of the antiquated tech, the theme is there. The view of artificial intelligence from the 80s is definitely dark. It shows mankind's distrust. Is this view that we have of artificial intelligence deserved? Do we need to fear artificial intelligence? In the late 1940s, polymaths like John von Neumann and Alan Turing jumped us from science fiction into the actual computer age. Turing wrote a seminal paper, with theories on whether or not machines think. I have a link on my website of his original paper. Also a link for Rotten Tomatoes for those movies I mentioned and the books. Anyway, John von Neumann was a brilliant mathematician. He delved into computer science before it was a science. In 1956, Arthur Lee Samuel, a researcher at IBM, played a game of checkers on television. See, I'm still staying away from chess. His opponent, a 36-bit vacuum tube computer made by IBM. Samuel had assigned each of the 64 squares on the checkerboard a different set of machine word identifiers. Then he programmed his IBM 700 computer to think, that is, to consider a few possible checker moves by evaluating the resulting board positions much as a human player might do. Samuel was a computer pioneer. Enthusiasm abounded about the potential of this new field, with high amounts of optimistic press coverage. And no chess games. Oh, here's a quiz question. When was the term AI coined? In 1956, during the Dartmouth Summer Project. This conference was a total bust, but it convinced the Defense Advanced Research Projects Agency, which is the central research and development organization for the United States Department of Defense, that it was time to fund AI research. During the 50s and 60s, computer scientists sketched out dreams and designs of advanced problem-solving machines that in many cases mirrored the robotic creations of science fiction novels. As an aside, if you'd like some science fiction book recommendations for your kids, I've got a post on my website. The link is in this post too. Anyway, all this enthusiasm dropped off as mathematicians and researchers struggled. Why? Because in the 1950s, computer processors could not store information, only spit it back out. In other words, computers could be told what to do, but couldn't remember what they did. That's very weird to imagine. Over the next half century, the 1950s until 2000, Many of the most ambitious fantasies of artificial intelligence were often met with prosaic real-world limitations. Progress was made, but slow progress. These long, fallow periods have been dubbed an AI winter. Plus, computer science was expensive. In the early 1950s, the cost of leasing a computer ran up to $200,000 a month. And I thought paying $2,000 for a laptop was expensive. Can you imagine time traveling to 1956 and renting out your laptop for $200,000 for 30 days? I'd be all in. I bet you would be too. In the 21st century, it may seem that AI is taking over, but innovations took time. Look at the history of flight. The Wright brothers flew at Kitty Hawk in 1903, but it wasn't until the 1930s that aviation saw the beginnings of commercial transport. And 100 years later, we're planning to go to Mars. To read a post about how to get to Mars, all you need to do is go to my website. Anyway, that was my brief history of artificial intelligence, with a few plugs for my other posts. Let's stay in the 21st century now, fast forwarding from the 1950s to our brief history of artificial intelligence. So, once that limit of computer storage was no longer, which was holding us back decades ago, was no longer a problem, we could start coding computers so they'd remember what to do. The power of machine learning snowballed. How do computers learn? When we humans give them data and parameters to look for, these instructions are called algorithms. For the record, a computer algorithm is a sequence of finite instructions that carry out a series of processes to respond to specific problems. In other words, an algorithm is a set of steps used to complete a specific task. Algorithms are the building blocks for programming, and they allow computers, smartphones, and websites to function. If you want to delve into algorithms, I've got a link on my website. Don't worry. We're avoiding the nuts and bolts of the algorithm aspect of machine learning in this podcast. Let's approach the question of how do computers learn with a recent success story involving supervised learning. In 2020, MIT researchers encoded the data of over 2,000 molecules into a computer. They included facts about these molecules, such as atomic weights, the types of bonds needed to inhibit bacterial growth. This is called a supervised learning approach. Once the computer, or AI, learned this data, researchers then instructed the AI to survey a library of over 61,000 FDA-approved drugs that would be effective as antibiotics. The drugs could not look like any existing antibiotic, and they had to be non-toxic. Imagine how long this would take a human researcher to do. Of all 61,000 molecules, only one fit the parameters. The researchers named the AI discovery Halicin. Halicin is effective against several bacterial strains, including multi-drug resistant bacteria. Halicin is an amazing win and an amazing artificial intelligence application. Bacterial resistance to antibiotics is a major worldwide problem. Researchers plan to broaden AI supervised learning approach to find more new antibiotics and to design molecules from scratch. Okay, if there is supervised computer learning, it follows that there is unsupervised computer learning. With a plethora of data, programmers can employ unsupervised learning to extract potentially useful insights. The algorithms in unsupervised learning can enable computers to discover hidden patterns or data groupings without the need for human intervention. Discovering similarities and differences in information make it the ideal solution for exploratory data analysis, cross-selling strategies, customer segmentation, and image recognition. Well, okay, we know there are still glitches to iron out with image recognition. From marketers to biologists to bankers to fraud specialists, unsupervised learning allows AI to find patterns or anomalies in the masses of data at our fingertips. Looking beyond the data, researchers seek to train AI not in a passive environment, but to operate dynamically. This type of AI learning is called reinforcement learning. Similarly to when I teach Louie how to do a trick and he gets a treat. Reinforcement learning is an iterative process where an algorithm seeks to maximize some value based on rewards for being right. It's a strange concept to grasp with AI. So, how do AIs get treats? Reinforcement learning with AI isn't quite the same as when I give Louie that treat, but it is a game-like situation. Let's look at a few artificial intelligence applications to explain. Take the technology for self-driving cars. Yes, there are still issues, but we won't delve into them in this post. An autonomous race car, let's say, is tasked to find the fastest lap around a track. The AI works to find the optimal sequence of steering, brake, and gas that achieves the fastest lap time. The algorithm learns to perform a task by trying to maximize rewards it receives for its actions. In the case of an AI, they receive points. Louie doesn't think this is effective because you can't eat points. But soccer players like points. Reinforcement learning is best when one doesn't have a lot of training data, cannot clearly define the ideal end state, or the only way to learn about the environment is to interact with it. Artificial intelligence applications encompass far more than self-driving cars, such as assistance with agriculture to facilitate administration of pesticides, detection of diseases, and prediction of crop yields. AI has detected breast cancer earlier than human radiologists by identifying subtle radiological features. AI can detect retinopathy, which is one of the leading causes of blindness, by using the power of machine learning to analyze retinal photos. If you're curious about bionic eyes, I've got a great post with research and cutting-edge tech that hopefully will help people who are having problems with their vision. Anyway, the power of machine learning can now facilitate high-volume processes for loan approval or denial, although I don't think I'd like an AI to tell me that I can't have a loan. AI has predicted hypoglycemia by analyzing medical histories. And of course, streaming services use AI to give us suggestions about what to watch based on our specific viewing history. Artificial intelligence and the future of humans is right now. The power of machine learning has potential to perform tasks from analyzing EKGs to reading video surveillance to detecting beach litter. Artificial intelligence applications for space include combing through data for exoplanets. And up to 70% of custom software development could eventually be passed on to AI. This is cool. I read that in 2021, AI was utilized to predict missing words, fragments, and sentences from cuneiform tablets that were up to 4,500 years old. So, artificial intelligence and the future of humans is now. What do you think? Do we need to be afraid? Which artificial intelligence do you find most intriguing? Don't get left behind. Subscribe to my website at www.susanberkkoch.com and keep your learning at AI speeds. Thanks so much for listening. Take care.